Hey 11s, there's a new video, simultaneous equations, what we're looking at here. Simultaneous equations. What this means is we have two equations, right? At least in most cases. We have two equations, each has two variables in them. So in this one here you can see I've got 3x, 2y, I've got x's and y's here, I've got another equation here with x's and y's. They've been conveniently labelled number 1 and number 2 for us. Right, if I had just one of those, I couldn't solve it. There's two unknowns, and really I've only got one piece of information. I've got two pieces of information, two unknowns. I should be able to solve that. We're going to look at solving these by substitution. A solution to this, right, unlike just solving a linear equation, where we find x equals, here I've got to find what y equals as well. I've got to get two parts to it, right? I need to find the value of x and the value of y. Now, by substitution means we make typically one of these variables the subject. So I'm going to rewrite this equation here. I'm going to rewrite this one. I'm going to say that y equals 24 minus 4x. I'm going to call that 3 now. Okay, y equals 24 minus 4x. I make y the subject of one of those. I could make x the subject of one of those, doesn't matter. Now what I'm going to do is I'm going to substitute it into the other one. So where there's a y here, I'm going to replace it with 24 minus 4x because they are equivalent. So I'm going to say sub 3 into 1. Now, if you sub it back into 2, you'll end up with a statement that says something along the lines of 1 equals 1, which is pointless. Now, I've got to substitute it into the other equation. Right, when I do that, I get, therefore, 3x minus, now I'm going to put brackets here. Instead of saying, minus 2 times. Instead of saying y, I say 24 minus 4x. Okay, that's instead of the y equals 29. Now I'm going to expand that out. 3x minus 48 plus 8x equals 29. That means 11x. I'm going to add 48 to both sides. It's equals 77. X equals 7. Not finished halfway there. X equals 7. Now, let's call that 4. Sub equation 4 there, x equals 7, into, doesn't matter. I'm going to say into 2. Doesn't matter. Doesn't matter. Work out the same. Therefore, now instead of x, I write 7. 4 by 7 plus y equals 24. 4 7 is 28. For y equals negative 4. Okay, there's my answer. Right, x equals 7. Y equals negative 4. You can get away with just circling them, put an asterisk or something so we can see those two things. We may, in some instances, write them as a pair of coordinates. Right, so 7, negative 4, with a comma in between the brackets. Because this does have a graphical representation. It does have a meaning in that sense. But that'll do us. I can see those answers. X equals 7, y equals 4. Don't stop halfway. Let's try it again. Here's another example. Y equals x squared, y equals x plus 2. I'm going to sub 1 into 2. Right, and that means that I get x squared equals x plus 2. Means that x squared minus x minus 2 equals 0. Then I get x minus 2, x plus 1 equals 0. Therefore, x equals 2 or x equals negative 1. Now I say we need two answers. Well, in fact, I need some answer for x and for y. Now I'm going to say let x equal 2. Therefore, y equals 2 plus 2 equals 4, and over here I'm going to say let x equal negative 1 for y equals negative 1 plus 2 equals 1. Right, so my solutions are, right, best to do it this time to very explicitly so they are. So my solution is at 2, 4 and or it doesn't really matter, and negative 1, 1. Okay, that's how we solve a pair of simultaneous equations by substitution. It's not the only way. of solving them, but that's all we're going to do in this video. Substitution, check it out.